morning again. We're going to continue our review of fractions. Last week, we talked about a fraction represents a part of a whole, a number less than 1. We also talked about the 3 types of fractions. You have a proper, improper, and a mixed number. We also defined what a proper fraction was. A fraction number is when your numerator, your top number, is smaller than your denominator, your bottom number. An improper fraction is just the opposite. It's a proper fraction upside down. It's when your numerator, your top number, becomes larger than your denominator, your bottom number. And then we talked about the mixed fraction or mixed number. That's a whole number and a proper fraction, such as 3 1/2, 5 2/3, 10 1/4. Those are mixed numbers. Today we're going to continue our discussion about proper fractions, what we can do with them, improper fractions, and mixed numbers, how they go back and forth. Let's get started. Proper fractions can only be reduced. An example, if I had 2/8, notice that's a proper fraction because my top number, my numerator, is smaller than my bottom number, my denominator. This fraction can be reduced. It can be reduced by 2. We always want to reduce the numerator and the denominator by the same number. In other words, all we're doing is dividing. Two will go into itself 1 time. 2 will go into 8 4 times. Therefore, the proper fraction 2/8 can be reduced to 1/4. In other words, 2/8 is the same as 1/4 of anything. Let's try another one. This fraction, 5/15, is a proper fraction. We want to reduce this fraction. It can be reduced. Remember, we always want to reduce the numerator and the denominator by the same number. And all we're doing is dividing. Let me erase my equal sign, put my division sign. We're going to reduce both numbers by the same number. And we always, when you're reducing a fraction, when possible, you want to use the largest number that can go into both numbers. It has to be the same number now, but we want to use the largest number. In some instances, you can't always figure out what the largest number is. So you can start with a smaller number. The only thing with that is that when you reduce it, you're going to have to reduce it again. But let's deal with 5/15. We're going to reduce both numbers by 5. Remember, when we're reducing, we're dividing. 5 will go into 5 1 time. 5 will go into 15 3 times. Therefore, 5/15 is the same as having 1/3 of something. It's the exact same thing. Now, let's look at a fraction where we don't start with the largest number and see how that works. We're going to take the fraction 8/24, proper fraction, and you know why it's a proper fraction. Just looking at this, I know that the largest number that can go into both 8 and 24 would be 8 itself. But let's say I don't know that. I do know, since both of these are even numbers, they're both reducible by 2. So we're going to start with 2. I can divide 8 by 2. I'm going to get 4. I can divide 24 by 2. I'm going to get 12. But now look at this fraction, 4/12. It's still reducible. So we continue. Now I can say, let's divide by 4. I know that 4 will go into itself 1 time. 4 will also go into 12 3 times. Hence, my answer becomes 1/3. I can't go any farther because the only number that can go into both 1 and 3, the same number would be 1 itself, and I'll still get 1/3. So, in essence, I started with 2, then I started with 4. So, actually, I reduced this 8/24. I can multiply these two numbers. 2 times 4 is 8. Remember, I started and I said 8 and 24 are both reducible by 8, and you see that because we reduced by 2 here. But when we got our answer, we could continue reducing this, and then we reduced 4/12 by 4, which gave us 1/3. So we reduced by 2, and then we reduced by 4, and when you multiply those two numbers, you get 8. Hence, 8/24 is actually reducible by 8. And so what I could have done, this is just to show you the process if you don't know the largest number. And I will show you, you would get the same thing. Eight will go into self 1 time. 8 will go into 24 3 times. Remember, if you have a proper fraction that's reducible and you don't know the largest number that will go into both numbers, find the smallest number that you know and start reducing that fraction. I guarantee you, you will arrive at the same process. Let's look at an improper fraction and a mixed number or a mixed fraction. They can both go back and forth. In other words, I can take an improper fraction and I can convert it to a mixed number. I can also take a mixed number and convert it back to an improper fraction. Let's see how we do that. Remember, what's the definition of an improper fraction? Exactly. Let's say we have 24/5. I'm dividing my bottom number into my top number. In other words, this is what I'm doing. I'm saying 5 into 24. Okay? So let's look at this. 5 will go into 24 how many times? Let us see. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. Notice, I can't go past 4 because when I get to 5 times 5 is 25, and 25 is larger than 24. The only number I have to work with is the 24. So I go back to 5 times 4, which is 20. 5 will go into 24 4 whole times. 5 times 4 is 20. Now, I'm going to take my product of 5 times 4, and I'm going to subtract it from 24. Remember, 20 is my product of 5 times 4. I want to subtract that product from the numerator, 24. 24 minus 20 is 4. I have 4 left over. I can't divide 5 into 4 because 4 is smaller than 5. So, my answer now, 4 becomes my numerator. My denominator 5 doesn't change. I bring it over. 24 fifths. 24 fifths is the exact same as 4 and 4 fifths. Let me show you why. Because remember, if I can go forward, I can also bag up and go backwards. Let's start with 4 and 4 fifths. If I can get 24 over 5 to become 4 and 4 fifths, I should be able to get this 4 and 4 fifths to go back to 24 over 5. The process is very easy. We're going to multiply, then we're going to add. When we do this process, we're always going counterclockwise. Okay? In other words, I'm going to multiply my denominator by my whole number. That product that I get, I'm going to add the numerator to it. That new number is going to become my numerator, and my denominator, which is 5, will stay the same. Let's see if it works. Remember, our denominator is 5. It's not going to change. So we're just going to bring it over. Now we're going to start the process of finding what the numerator will be. Remember, we're going clockwise. We're going to say 5 times 4 plus 4 On last week, we talked about order of operations. Remember, when we're doing order of operation, pretty please, my dear Aunt Sally, or please excuse my dear Aunt Sally. Multiplication always takes precedent over addition and subtraction, unless the addition and subtraction is inside of parentheses or it's inside of groups, group symbols. We don't have any grouping in here, so we're going to start with 5 times 4 is 20. To that, we're going to add 4. Remember, we bring our 5 over. Our denominator doesn't change. Better looking for. 20 plus 4 is 24. The denominator doesn't change. We just bring it over. 24 over 5. Therefore, you see 4 and 4 fifths will go back to 24 over 5, which is an improper fraction. This is very important to know how to do. So let's go through this process one more time. We start with an improper fraction, 24 over 5. We want to change that to a mixed number. So we're going to divide the denominator into the numerator. 5 will go into 24 4 whole times. 4 whole times. Then we're going to multiply the denominator by the numerator, which is going to give us 20, and we're going to subtract that from the numerator. 24 minus 20 is 4. This answer becomes the new numerator. We bring the 5 over, 4 and 4/5. Now we want to change that 4 and 4/5 back to what it was, 24 over 5. We use the process of multiplying and addition, and we always go counterclockwise. We bring our 5 over. The denominator does not change. So we're going to say 5 times 4. To that product, we're going to add 4. Bring the 5 over. 5 times 4 is 20 plus the 4. 20 plus 4 is 24. We bring our 5 over, and again, we have 24 over 5. I've just shown you this process. Now, make up some improper fractions, change them to mixed numbers or mixed fractions, and then see if you can go back and use this process. This is all we will cover for today. Thank you for your attention.